So I'm making this movie in a slightly different way, and I want to see what you think of it, because if I can make movies, some of the movies at least in this way, it will make things an awfully lot more efficient for me, and I'll talk about that later if you decide this is okay. So anyway, we're staying on algebra here, and we're just going to start off by something that I'm not overly sure is that important. I certainly haven't thought about these things since I was actually learning algebra myself many decades ago, but it's here, so I might as well put it there to you. And that is the differences between expressions, equations, formulas, and identities. An expression is something that you have seen quite a lot of lately, and it's a statement with one or more algebraic terms. So x squared plus 7 over 4x is an expression. It means absolutely nothing. It's just a statement that has two algebraic terms, an x squared and a 4x. Now you can actually give this a little bit of relevance by turning it into an equation. An equation is simply an expression that has an equal sign. Thus here x squared plus 7 over 4x equals 2. This actually means something. There is a defined, at least one defined value of x here that fits this equation. Now sometimes equations are really important and they actually have a relevance. They solve a problem, they can relate physical quantities and so on. And of course when we're into chemistry, just about every equation we see will be coming ultimately from a formula. So an example of a formula, a squared plus b squared equals c squared. The Pythagorean expression there tells you got a right angled triangle, one of the lengths is a, one of the lengths is b, the hypotenuse is c. We'll be talking about this in a couple of weeks, of course. Then a squared plus b squared equals c squared. While this is indeed just an equation, because it is an expression with an equal sign and 1, 2, 3 algebraic terms, it means something. Now the last thing, an identity, I queried in my mind whether or not it was worth talking about it, but it's there, we might as well define it. An identity is an equation that is true for all values of x. So for example, this equation here was only actually true for two values of x, but an identity is an equation that's true for all values of x. A lot of times you can think about it in a redundant sense, because most identities we're just applying without even thinking about them. But for example, an equation like this, 3x plus 15 equals 3 into x plus 5. It's an equation, right? We've got an expression, so we've got a couple of algebraic terms in there. It's an equation, we've got an equal sign, but it doesn't matter what the value of x is, this is always true. It is an identity. A lot of times you'll write an identity in this fashion, 3x plus 15 is equivalent to, is what that little 3-line sign means. I use that symbol much more for a triple bond, but it means it's equivalent to 3 into x plus 5. Not really a huge amount of sense to this movie in some ways, but it is important that you understand when I say expression, I mean in a statement with one or more algebraic terms. An equation is an expression with an equal sign. A formula is an equation that actually has some use. An identity is usually redundant. So let us now focus the rest of this topic on equations. And again, this is something that some of you are going to be really good at, some of you are a little bit rusty at. It's many of the tricks in here, not tricks, many of the tools, many of the devices are things I've already had to use as we've gone through, whether it being in the maths class or in the chemistry class, but it is worth just having this here as a reference point. So solving equations. Okay, equation, remember, is an expression with an equal sign. As long as it's not an identity, that means there must be a solution to it for specific value or values of x. So the general rule with solving equations is that you want to manipulate those equations, and the way you do it is whatever you do to one side, you have to do to the other. Thus, for example, x plus 5 equals 7. What is it that is screwing us knowing what x is exactly? And the answer is it's that plus 5. If that plus 5 wasn't there and it was just x equals something, the equation would be solved. So how do I get rid of a plus 5? Well, I subtract 5, because x plus 5 minus 5 would just be x. But of course, whatever I do to one side, I have to do to the other, so I have to subtract 5 from both sides. So x plus 5 minus 5 equals 7 minus 5, thus x equals 2. See, algebra is a piece of cake. Let's just quickly run through some other examples. X minus 5 is 1. What's wrong there? What's affecting us knowing exactly what x is? Well, that minus 5. How do I get rid of a minus 5? I add 5. But again, I have to add that 5 to both sides. So I will get x minus 5 plus 5 equals 1 plus 5. Thus x equals 6. 3x equals 12. What is it that's affecting my knowledge of x? Well, it's that nasty little 3 there. Now that's 3 times x. How do I get rid of a 3 times? I get divide by 3. So if I divide both sides by 3, I get 3x over 3 equals 12 over 3. Thus x equals 4. Okay, the 3's here cancel out on the x. 12 over 3 is 4. Multiplication, x over 2 equals 6. What is it that's messing us up? It's that x divided by 2. How do I get rid of a divided by 2? I just multiply by 2. So I get 2x over 2, so those are going to cancel out, leaving us just with x is 6 times 2. Thus x equals 12. Isn't this fun? Again, whatever you do to one side, you do to the other. So let's get a little bit fancier here. There's a thing called cross multiplying that essentially just means that if you've got fractions on both sides of an equal sign, if you multiply in that way, so we get 9 times x equals 2 times 4, which is 8. Thus x equals 8 over 9. Now, to do this cross multiplying, what we're essentially saying is we're going to multiply, first of all, both sides by 2. Well, if I multiply both sides by 2, well then I get 4 times 2 there, and I would get 2x over 2, which is just x there. Now I've got this 9 here to get rid of, so I'll multiply both sides by 9. Okay, and so there the 9 would cancel out and the 9 would go up in front of that. So I'm still with cross multiplying both sides, doing the same thing to both sides. It's just there's a lot of inherent cancelling out that goes on there. Another thing to think about, square rooting. I want this in your heads very early on. 4y squared equals 9. Well, if I get rid of that square by square rooting both sides, square root of 4 is 2, square root of y squared is y. Square root of 9 is either plus 3 or minus 3. Remember that. Square roots, you've got the plus and the minus possible values. So this particular equation has two values of y. Y is equal to 3 over 2 or minus 3 over 2. Other indices, again, as long as you bear in mind whatever you do to one side, you've got to do to the other. So imagine here I've got the cube root of x equals 4. What is it messing me around with knowing the value of x directly? It's that cube root. How do I get rid of cube root? Let's cube both sides. So the cube of a cube root is just x. Cube of 4 is 4 cubed, which is 64. Whatever you do to one side, you also do to the other. So that's of course a quiz with quite a lot of practice ones in here to be sure that you go through and try out.